So this korsmitron is observed to move towards the negative plate. That means the korsmitron is a positive charge because it's going to go towards the negative plate. The distance to the plate is 1 centimeter. It's halfway between the 2 centimeter separated plates. So based on the title of the question, we're dealing with the acceleration here. So we're going back to dynamics. The acceleration is going to be the net force divided by the mass. Now both sides of this equation can be adjusted a little. The left side, the acceleration, can be adjusted based on the big five equations with kinematics, because we're given that it starts at rest. It ends with a velocity of 1.0 times 10 to the 6 meters per second left. And the distance, or the displacement, is 1 centimeter, or 0.010 meters left. So the acceleration can be gotten with the big five equation. The fifth one. Okay, so rearranging it for acceleration, it's going to end up being v2 squared over 2 displacement. Okay, so I'm going to substitute this equation into my Newton's second law equation. So it'll be on the left side here, final velocity squared over 2 times displacement. Now on the right side, I like the over m part because our whole goal of this question is to calculate Q over m, the charge to mass ratio. The net force I'm going to replace with the force due to the electric field. So force equals charge times electric field. And that's my replacement. So I can kind of see I've got a Q over m right there. All I have to do is divide both sides by E. And that ought to do it. Okay, so I'll put in the values. All these values are to the left. Yeah, the final velocity is to the left, the displacement is to the left, the electric field is to the left. So they're all to the left. I just wanted to make sure I took care of that detail. Okay, the electric field is given right there. Okay, calculator time. So I'm coming up with 8.3 times 10 to the 8. So what would the units be of charge over mass? So charge is coulombs over mass would be kilograms. So it's on the order of 10 to the 8. Is that a reasonable number? Well, I mean, a korsmitron can be anything. Like, it's a fake thing. There's no such thing. So, but let's go back to the proton. For a proton, charge to mass was actually approximately 10 to the 8. So yeah, it's at least on the same order in terms of power of 10.